A term that chemists use to describe the absorption of heat during a physical or chemical reaction is endothermic. Endothermic means that the reactants absorb heat energy as they transform to products. Most chemical reactions are not endothermic, but two endothermic physical reactions that we are familiar with are vaporization and melting. When water transitions from the liquid to the gas state, it must absorb heat. The gaseous water molecules have more kinetic energy than the liquid molecules. They must get that energy from somewhere. The heat can occur in the environment naturally, such as when sweat evaporates from our skin. The water in the sweat removes heat from our skin and thus helps to cool us. Alternatively, we can apply heat to water to make it vaporize, such as when we boil water on a stovetop. For ice to melt, it must absorb heat, and thus is an endothermic process. Liquid water has more kinetic energy than solid water. That kinetic energy has to come from somewhere. Both of these processes are endothermic. The products have more energy than the reactants. The opposite of endothermic is exothermic. Most chemical reactions are exothermic or release heat. The release of heat means that the product chemicals are more stable than the reactant chemicals. Two physical reactions that are exothermic are freezing and condensation. Both of these processes release heat. Combustion or burning and the reaction of acids and bases are two examples of chemical exothermic reactions. The products have less energy than the reactants, and this energy is released as heat, and the temperature of the surroundings increases. There are dozens of exothermic reactions occurring in our body right now, which generate the heat needed to keep our body temperature constant.